Good morning. So today we're looking at solving triangles that are not right angled. Okay. To calculate the length of sides and the size of the angles of a triangle that are not right angled, we'll use one of the rules depending on the given information. These rules are called either the sine rule or the cosine with the cos rule, better known as. Okay, so the sine rule, so that is on page 339. Yeah, the proof of the sine rule is given. Okay, it's not examinable. So if you want to know where it comes from, you can go through page 339. Okay, and you can work through the proof of the sine rule. Okay. To apply the sine rule in any right angle, in any triangle ABC, the sine rule states that sine of A, this is now coming from that proof, okay? Sine of A over A is equal to B, is equal to sine of B over B, which is equal to sine of C over C. Or I can take its reciprocal, okay? It's a reciprocal equation is A over sine of A is equal to B over sine B is equal to sine C over sine C. Very importantly, if you're going with angles, and then angles will stay on top throughout. Otherwise, if you go with the lengths on top, it will be the lengths on top throughout. Okay. When using the sine rule, you need to have at least one angle and the side opposite the given angle. Okay. When you are given two sides in a non-included angle, alright, very important for the sine rule, it will be a non-included angle if two sides are known. Okay. Otherwise, if you got the angles, if we have two angles, of course, the third angle can be calculated using the angles in a triangle rule. Okay. So here we are told when given two angles in one side of a triangle, start by calculating the third angle of the triangle using the fact that the angles of a triangle adds up to 180. That is the sum of triangles rule there. Then calculate the unknown side opposite one of the given angles. Okay. So yeah, as those two sums indicates. Okay. So I'm going to do the examples and a few sums out of the exercise. Okay. Okay, now we're looking at example 1 on page 341. We are told solve triangle ABC. So if it says solve triangle ABC, you must calculate all the sizes of the missing, all the lengths of the missing sides and angles. Give all answers correct to one decimal place. Okay, so we can start off by saying, okay, there's one angle there. There's an angle there, so we can calculate the angle there. So angle A is equal to 180 minus 36 degrees minus neat here, 36 degrees minus 42 degrees, which gives me angle A to be 180 minus 36 minus 42 gives me an angle of 102 degrees. Okay, it's 102. So let's fill this in on the diagram. Okay. Now to calculate one of the sides now. So we know that sine, remember this is a non-right angle triangle, so it's going to, we can work out A over sine A is equal to B over sine B is equal to C over sine C. Okay. So A is unknown, so you make A over sine of 102. So you will ask the question now, why didn't I go with sine of A over A is equal to sine B over B is equal to sine of C over C? There would be no problem if I had gone that route. However, A is the unknown. So if I want to calculate the length, I use this formula. If I want to calculate an angle, I normally use the other formula. Okay. So if you had used sine over sine A over A is equal to sine B over B is equal to sine C over C, at this point there's no blame on that, no issue on that. Okay, it's equal to B. B is also unknown, over sine of 36 is equal to angle C. Now length C is 5 over sine C which is 42, sine of 42 degrees. Okay. So as you can see here, we that is our known ratio. Okay. So I'm going to use that known ratio to calculate B, or I could have gone with that known ratio and calculated A. Okay. So I'm going to go and calculate A first. So I'm going to calculate B first. So what I'm going to do is I'm going to cross multiply. Okay. So in other words, this is what you see only now. Okay. We can't solve both at the same time. Okay. So we solve one of it at a time. So we cross multiply. So B times sine 42 is B sine 42 is equal to 5 sine 36. So I divide by 42 both sides. So I got 5 sine 36 over sine 42. Okay. So let's put this in the calculator. So we will have 5 sine 36 over sine 42. Okay. It gives me an answer of 4, 4. 4 centimeters. Okay, otherwise on the other side we're going to use sine A over sine 102 is equal to 5 over sine 42. I could have also said that A over sine 102 is equal to B over sine 36, but I must got B to be 4.4. You could have put 4.4 in there as well. But if I have a choice of what to use, I'd rather use what is known to me. Okay, because if you had made a mistake here, it would filtered into a mistake into the next answer. Okay, so I'm going to rather end off by saying that A over sine 102 of course is equal to 5 over sine 42. Okay, so what we do here again, we cross multiply, so that would simply be A sine 42 degrees is equal to 5 sine 102. So to get A on its own, I divide by sine 42 both sides. So it's 5 sine 102 over sine of 42 degrees. So let's put that in our calculator. 5 sine 102, close brackets, is over sine 42. Okay, that gives you 7,3 centimeters. Okay. Okay, so in example 2 on page 342, we are given triangle LMN. Okay, so we got the triangle LMN with angle M being 82 degrees. Okay, LM, so LM here, which is this length here, it's going to give you 6 centimeters. LN is going to be 10 centimeters. So you see there's two lengths and a non-included angle. Calculate the size of angle L. So what we know at this point is that sine of angle L over L. Remember, this is L, that is M, and this is N. Okay. So we got L over L is equal to sine N over N is equal to sine angle M over lowercase m. Okay. Why did I go with sine over the length? Because I'm going to calculate an angle. So at this point we can say, okay, what do we have? Let's fill in what we have. We've got sine of L, which is unknown. That's what we want to calculate, over lowercase l, which you also don't know. Okay. Then we've got sine of N, which is unknown. But N's length opposite that is to be 6. Sine of M, which is 82 over 10. So as you can see here, we have the known ratio. We have, and that is one unknown in that ratio. So at this point we can calculate N. We can't calculate L straight away because we don't have the length to do that calculation there. We don't have the length of L. So just take this out. Whoops. I went too far. Okay, let's go again. So it will be N, which is 6, equals sine M, which is 82 over 10. Okay, so what I'm going to do is I'm going to calculate N first. Okay, as I said, you can't calculate L because I'll be shorting that length there. Okay, so what I'm going to do is I'm going to take that 6 up. So that is going to be sine of angle N is equal to 6 sine of 82 over 10. Otherwise we could have cross multiplied. That would have then given me 10 sine N equals 6 sine 82. Then divide both sides by 10 to get sine N on its own. Okay, so to calculate angle N is going to be arc sine of this here. So that I'm going to put on the calculator. So you're going to give you 6 sine 82 sine 82 close brackets over 10 gives us 0.59. Of course the number carries on. Okay, just put the arc sine of that. No? So it's shift sine or arc sine of 0.59. Alright, so put that in the calculator. Shift sine or arc sine. You put, remember, if I press this answer button, that's the last answer calculated on the calculator. So you press shift sine or arc sine of that answer. Okay, so that angle N works out to be 36, 5 degrees. Okay, 36,5 degrees. So if you now relate that back to the diagram, so it's going to be 36.5. So how can I calculate angle L? You can use sum of triangles, okay, or angles in a triangle. So angle L is going to be 180 degrees minus 36.5 degrees minus 82 degrees. It gives me an angle of, so it's 180 minus 36.5 minus 82. That gives me an angle of 61.5 degrees. Okay. Now we will be looking at a couple examples with regards to this exercise 10.3. Okay, so in 10.3, exercise 10.3, and it's on page 343. We are told that in this exercise, give answers correct to one decimal place where necessary. This question says, calculate the length of AB. Now AB is also lowercase c if you want. Okay. So what can be calculated? As you can see, we have two lengths. We can calculate angle A at this point. Okay. As you can see there. So angle A is going to be 180. Okay, wait. Sorry. So 180 degrees minus 24 minus 62 degrees. Okay, so that gives us an angle of 62. It'll give you 94 degrees. Okay, so I've populated the diagram there. So we can now say that sine of angle A over A, in this case is BC, is equal to sine. Remember, they want you to calculate the length. So normally we would say the length over the sine of the angle, but I'm just showing you here, it will just take an extra step. Okay, so this would be sine of B over AC is equal to sine of C over AB. Okay, instead of saying sine of A over A, I can say sine of BC, a sine of A over BC, and sine of B over B, it's going to be sine of B over AC, and sine of C is going to be over AB. Okay, so if we take this into account now, so we're going to say sine of angle A, which is 94 degrees, over BC equals sine of angle B, which is 62 over AC, which is 7, and there's my known ratio, equals sine of C, which is 24 over AB. Now looking at what is asked, I want you to calculate AB.